Okay, lesson 2.2, linear equations. Hopefully this is all review from Algebra 1, but I know how we can forget. All right, here's what we're starting with. Linear equations, an equation that has no operations other than addition, subtraction, and multiplication of a variable by a constant. And we usually say x is our constant there. Let's jump down to the bottom. A linear function is a function whose ordered pair satisfies a linear equation. Oh yeah, that's really helpful. All right, so we have all kinds of different relations between numbers. One of our special relations that we have right now is what we call a linear relationship. And when it's linear, it is a function. So we say it's a linear function. All right, here we go. We're going to pull them out here. This one is a linear equation. If it doesn't bother you too much, I'm going to rewrite this as y equals 5 minus x because it looks more like that slope-intercept form that you like. Our x is only to the first degree, y is to the first degree. We can multiply with it, but we are not subtracting. We're subtracting or adding, but we are not dividing by a variable here. This is not linear because we have x to the second power. We have a y to the second power. Uh-oh. This is not going to be linear because we have that square root. It's not just a regular x, it's a square root of x. 2/3 x, that one will be linear. If the x were in the denominator, that'd be different. Here we have x to the 5th power and an x as well. That makes it not linear. 2 minus x over 11. I still think we're good here. We have, this is actually 1/11 x. So that is going to be a linear equation. Oh, I think that might be, oh, there's one more over here. Uh-oh, they're all grouped together somehow. Ungroup them. Oh no, oh no. Okay, we're just gonna hide those. I think you got the idea because I got more on the next page. Is it linear? Is it not linear? I'm just gonna let you guys try it out. You're gonna put down example 1, A, B, C, D, E, F. You go to town, you can put down linear, not linear, and then we'll check in class. Remind me to check in class. Example 2, the linear function f of c, yep, that's how you say that, f of c is equal to 1.8c plus 32, can be used to find the number of degrees Fahrenheit f that are equivalent to a given number of degrees Celsius c. On the Celsius scale, normal body temperature is 37 degrees Celsius. What is that in degrees Fahrenheit? So basically, we already know the C value is 37 degrees. So instead of writing f of c, we put f of 37 equals 1.8c. This is where I'm going to put in, oh, not 33.7, 37 plus 32. All right, equals 1.8. Let's go to a calculator here. 1.8 times 37. 66.6 plus 32. Add those together, I believe we get 98.6. All right, so your function, if you want to find 37 degrees Celsius, that's going to be 98.6 degrees Fahrenheit. Example 3, in meteorology, the linear function, notice how we have a linear function here, d of s is equal to 1/5 s, can be used to find the distance in miles from a storm based on the number of seconds s that it takes to hear thunder after seeing the lightning. So you've ever heard a storm coming, if you can see the lightning, count how many seconds. They say take those seconds, and basically this is a fancy way of saying divide by 5. So if you hear thunder 10 seconds after seeing the lightning, how far away is the storm? So d of s, we're going to put in 10 because we're actually saying 10 seconds later is 1/5, and instead of writing s, I write 10. So d of 10 equals 1/5 times 10, which is equal to 2, because it's actually 10 top times the top, bottom times the bottom, or you can say 10 divided by 5 is a whopping 2. So if you hear or see the lightning 10 seconds, see the lightning 10 seconds later you got thunder. you know that we are looking at 2 miles. 2 miles till that storm gets to your place. Same kind of problem. However, if the storm is 3 miles away, how long will it take to hear the thunder after seeing lightning? So now you know how far away it is. We want to figure out, well, what would be the space between the lightning and the thunder? Well, now this amount right here, d of s, is the distance. So I'm going to say 3 equals 1/5 s. How do I solve for s? I want to undo 1/5. That means I take both sides times 5 over 1. You can just say it times 5 and you'll be fine. All right, this 5 cancels, so I have s equals 15. And this should be 15 seconds. Oh yeah, because I'm solving for s, which is 15 seconds. Okay, once again, every section is jam-packed with information. So, not a whole new lesson, but a whole new idea in the same lesson. Standard form. ax plus by equals c. It should look familiar. That is standard form. You will have to know this on every quiz, every test from here on out. What's standard form? Standard form. ax plus by equals c. Notice, a, b, and c cannot, this is basically saying whose greatest common factor is 1. No fractions. Okay? No decimals for a, b, or c. Okay? And a plus, a must be positive. Because it says a is greater than or equal to 0. That's our way of saying a must be positive. So you lead in with a positive number right away. A and b cannot be 0. They're not both 0. All right, it normally looks like this, like 2x plus 3y equals 6. That's kind of a typical standard form. All right, let's go with this. Right, y equals 3x minus 9 is standard form. Identify a, b, and c. So we want it to look like this. I want my x's and my y's on the left side of the equal sign. Here is my equal sign. My y is already over there. It's this that's got to get moved. So to do that, I'm going to subtract 3x from both sides. Okay, notice I can't take y and 3x and subtract. This cancels out. I just have to write it like 3x. This is still a positive y equals, this is a common mistake in Algebra 1. Let's not make it in Algebra 2. This is still a negative 9, not just a boring old 9, negative 9. In addition to that, we have got to make sure the lead-in number is positive. We want to start this thing out right. We're not starting with some negativity. No way, Jose. So how do I do that? I take the entire equation times negative 1. So now this becomes a 3x, and this negative 1 times y becomes a negative y, or plus negative y, and now I have a positive 9. So 3x minus y equals 9. Okay, that is your standard form. This works. For some reason, I just have to go back. I know my Algebra 1 students, when we start with this, there's this thinking that they both have to be positive or they both have to be negative. No, the lead-in has to be positive. And then after that, like if I were to do this myself, I would just think switch, switch, switch the signs so my lead-in is positive. All right, example 6, look at this. Negative 2/3 x equals 2y minus 1 in standard form. Oh, and then have to identify a, b, and c. Once again, we want our x's and our y's on the left side of the equal sign. Notice how the x is already on the left. That means I have to move the y to the other side. So I'll do that by subtracting 2y from both sides. Gone. I'm going to write this in order. I like my x's first. Negative 2/3 x minus 2y equals, don't forget the negative that goes with the 1. All right. Now, you're like, wait a minute, didn't you say a couple screens ago I can't have a fraction? You cannot have a fraction. And it's negative. We could kill 2 birds with 1 stone. What a horrible saying. Let's take care of 2 things at once. Let's multiply by the denominator, because when you multiply by the denominator, it cancels itself out. You just have to make sure the rest of the equation follows suit. If I were to multiply by 3, this would become negative 2. So I'm going to be sneaky and make it negative 3. Because negative 3 times negative 2/3, 3's cancel, negative times negative is positive 2. Or you can think 3 times 2 is 6, 6 divided by 3 is 2. All right, enough explanation on that. 2x, negative 3 times negative 2, you have to multiply the whole thing. Negative 3 times negative 1 is plain old 3. This is standard form. Your A value is 2, your B value is 6, your C value is 3. Moving on. Example 7, you're on your own. You're going to put that in standard form. This is probably one of the easier ones you could possibly get. Example 8, I'll do this one with you because we got that fraction in there again. All right, 3/5 x equals negative 3y plus 2. I need to get my x's and my y's to the left side. This negative 3y needs to come over here. How do I do that? I add 3y to both sides. Now I have 3/5 x plus 3y equals 2. Then I have that fraction. We can't have fractions. No decimals, no fractions, basically, is that what that gibberish in that box says to you. Take everything times 5. This is my solution to this. So 5 times 3/5 is actually 3x. 5 times 3 is 15. 15 divided by 5 is 3. 5 times 3y is 15y. 5 times 2 is 10. There it is, standard form. A value is 3. B value is 15, C value is 10. All right, even more x and y intercepts. The x-coordinate of a point at which the graph crosses the x-axis is your x-intercept. Because this is your x-axis, this is your y-axis, so this is your x-intercept. Y-intercept is the y-coordinate of the point at which a graph crosses the y-axis. Here's your x-axis, here's your y-axis, there is your y-intercept. By the way, on this graph, this is your y-intercept, and this is your x-intercept on the graph. Example 9, find the x-intercept and the y-intercept of the graph of negative 2x plus y minus 4 equals 0. Now, basically, if you put in 0 for x, you're going to get out the y value will be your y-intercept, and vice versa. Here's what I'm going to suggest. I think we should go straight to standard form. You don't have to. There might be some of you who feel comfortable without, but I'm going to rewrite this. Negative 2x plus y equals, I'm going to add 4. All right, and then I suppose since I said standard form, let's make it correct. Switch all the signs. Okay, now here's what I do. This is what I go, and if you had me for Algebra 1, you remember this, but you don't remember really what it goes with. 0 blank, blank 0. 0 blank, blank 0. That's the thing I'm learning over time. Do we really have it when I say that? You're like, what does that go for? This is helping you find your x and y intercepts. If you think about it, anywhere on this axis has like 0, negative 4. This is 0, 3, 0, whatever this is, 6. Okay? They all start with zeros. So these are your y-intercepts. Anything that starts with 0 is a y-intercept. Anything that ends with 0 is an x-intercept. That's going to be huge. We've got to have that down solid. Okay? Now, with that said, normally I'd use my hand, but I can't really show the hand thing, so this is going to be my pretend hand or my pretend finger. If I want to know where my x value is 0, then I'm going to put 0 in for x. Well, what is 0 times 2? 0. That's my pretend canceling it out. You don't see it. My hand is covering up. So now negative y equals negative 4. What is y then? Well, y has to be 4. Okay, so I'm going to put a 4 in this spot. All right? Either that or you need to write it out. You need to put 0 in for x and then solve for y. I kind of try not to show you that. I try to do this other method as well. All right, now over here, can you see how my x-intercept has a y value of 0? That means this really isn't here. That means 2 times something gives me negative 4. Well, isn't that negative 2? 2 times negative 2 gives me negative 4. So that is my x-intercept. So now I graph 0, 4. I graph negative 2, 0. Got 2 points. I can make the x and the y-intercept. the minimum number of points it takes to make a line? 2. Well, I've got my 2, and now I can make a straight line, I think. Oh, I bet I don't have my, oh, not good. Not good. Let's just pretend this is not coming up here. Okay. Sorry, guys. Bad drawing of line, but you got the idea, right? Okay. Example 10. X and y intercept of the graph 3x minus y plus 6 equals 0. Okay. Once again, I'm going to go with that standard form. I'm just going to set it up like that. I have to subtract 6 from both sides. I want to know my x and y intercept. 0 blank, blank 0. I get out my little finger that's going to cover things up. Okay. If I put 0 in for x, then this comes over here. We're pretending that's not there anymore. So now my equation is, oops, negative y equals negative 6. Doesn't that mean y equals 6? That comes right in there. Now I have to start over again. Now I'm saying 0 goes in for the y value. So I go up here and I cover up my y value. Pretend you can't see it anymore. 3x is equal to negative 6 is what I got written out now. 3x equals negative 6. That means x equals negative 2. This is your y-intercept. You could graph it if we had graph paper. And this is your x-intercept. Okay, and then you just have a little graphing extravaganza. And we are calling this good. A lot of information. That's about a whole chapter's worth, well, maybe not a whole chapter, of Algebra 1 in one day, and probably more like 15 minutes.